All right, for 61, we are not allowed to leave a radical in the denominator. And so I need to get rid of this square root of 3. And the way that I do that is by multiplying by the conjugate. It's the exact same numbers, but the opposite sign in between. So I'm going to keep the 1 and the square root of 3 the same, but change the plus to a minus. And what I do to the bottom, I also do to the top. So in my numerator, I have negative 2 times 1 minus the square root of 3. And the denominator, I'm going to FOIL. So 1 times 1 is 1. 1 times the negative square root of 3 and 1 times a positive square root of 3 are going to cancel each other out. And then positive times negative is a negative. Square root of 3 times square root of 3 is square root of 9, or 3. So 1 minus 3 is all that's left in the bottom. That's negative 2. And so I can cancel the negative 2 in the top with the negative 2 in the bottom because this is being multiplied. Remember, you can't cancel things being added and subtracted, but you can cancel things being multiplied. So that leaves me with 1 minus the square root of 3 as my answer. All right, then 62, we have a radical that we're trying to solve. So you need to get the radical alone on one side by itself. So first thing I'll do is add 5 to both sides. So the radical is alone. Then what gets rid of a square root is a square. It's inverse. So we're going to square both sides. So the square root and the square cancel each other out, and 8 squared is 64. So now to get x by itself, we're going to add 4 to both sides and then divide by 2, and we'll get x equals 34. And when we plug that back in to check it, it does work, so we know that it's not an extraneous root. For number 63, when you have an absolute value equation, we're going to take what's inside the absolute value and set it equal to a positive and a negative of what's on the other side. So we took what was inside the absolute value, 2x plus 5, and set it equal to a positive 7 and a negative 7 because we set it equal to a positive and a negative of what's on the other side. Then solving is straightforward. So subtract 5 from both sides and divide by 2. Subtract 5 from both sides and divide by 2. So the two solutions that you get, again, when we plug those back in for x, they do work. So neither one of those are extraneous roots. All right, then for 64, we have a compound inequality. That's just two inequalities put together. All right, so for this first one right here, if I want to get r by itself, I'm going to add 2 to both sides, and then I'm going to divide by -7. Now remember, when you divide an inequality by a negative, you multiply or divide by a negative, we have to reverse the inequality sign. So that's going to give me r is less than -1. So we're going to go from -infinity to -1. All right, then for this guy, let's subtract 7 from both sides. And so we'll have 6r is greater than or equal to 0. Divide both sides by 6. And we'll have r is greater than or equal to 0. So we're going to use a bracket with the 0 since we're equal to, and all the values greater than would go off to positive infinity. And then we just put the little union symbol in between to show that both pieces are my answer. All right, 65, we have a piecewise defined function. And so when they ask me to find f of 5, I am not going to plug 5 into this equation and into this equation and get two separate answers. You can see I only get one. I have to figure out, is 5 less than 2, or is 5 greater than or equal to 2? Well, of course, 5 is greater than or equal to 2, so that tells me to use this piece of the function, not this piece. So I'm going to use x squared plus 2, and I'm going to put 5 in the place of x. 5 in the place of x would give me 25 plus 2, or 27. All right, then for f of 2, is 2 less than 2? No, but is 2 greater than or equal to 2? Yes, 2 equals 2, so that tells me I'm going to use x squared plus 2. So put 2 in the place of x, and that's going to be 2 squared, or 4 plus 2 is 6. All right, and then f of 0, 0 is less than 2, so that means I'm going to use the 3x minus 1 piece. And so 3x minus 1, if I put 0 in for that x, then I'll get -1. All right, 66, we have a composition of two functions. So let's start with g of f of x. I'm going to replace f of x with what it's equal to, which is x squared. So now I have g of x squared. So g of x squared means put x squared in the place of x in this function. So that would just be x squared in the place of x in the function, and this would be my answer. We also can do that with numbers. So like g of f of 2. So let's start on the inside with f of 2. So f of 2 means put 2 in for x, so that would be 2 squared or 4. So since f of 2 equals 4, replace f of 2 with 4. Now I have g of 4. So g of 4, I'm going to put 4 in the place of x, 4 in the place of x, and that gives me square root of 9 or 3. All right, then for this next one, they want to first off know where it's increasing. Okay, so increasing is just where it's going up, of course. So you can see right here it's increasing, and then it's decreasing, and then it's increasing. So we're going to use the x values, and we're going to use parentheses no matter what. All right, so the first x value that we come to is this -4 right here. All right, so it's increasing from -4 to -2, and then it's increasing again from +1 to +3. So that's where we got this right here. All right, then it's decreasing from -2 to +1. So again, x values, right? And always using parentheses. And then we have a maximum at -2, 3. A relative maximum is where you change from increasing to decreasing. And then we have a relative minimum at 1, -2. A relative minimum is where you change from decreasing to increasing. Now, remember that endpoints can be absolute maximums and minimums, but they cannot be relative maximums or minimums. So the absolute maximum is the one absolute highest point on the graph. So that's at -2, 3. And the absolute minimum is at the one absolute lowest point on the graph. That's at -4, -3. So an absolute maximum or minimum can occur at a relative maximum or minimum or at an endpoint. All right, then for 68, they want us to use the graph to find the average rate of change from -2 to 1. All right, so they gave me two x values. I need the y values to go along with them because rate of change, average rate of change is just slope. So I need two ordered pairs in order to do that. So they've given me the x's, I need to find the y's. So when x is equal to -2, y is +3. So there's my first point. And when x is equal to +1, y is -2, there's my second point. So I'm going to do y2 minus y1 over x2 minus x1. So that's going to give us a -5/3 for our average rate of change. All right, for our next one, they asked me, is the graph relation a function? All right, well, if it's a function, it has to pass the vertical line test, meaning if I draw a vertical line, I don't hit it in more than one spot. And this one fails. So no, it is not a function. If it's not a function, it can't be a one-to-one function. So in just a second, when we get down here and it asks us, is it a one-to-one function? It's not even a function, so it's not going to be one-to-one. The way to tell if something is a one-to-one function is it has to pass both the horizontal and the vertical line tests. All right, so domain and range. So we're looking for our x values going this way. So you can see this is going to keep going off to -infinity. This is going to keep going off to -infinity. So our x values are going to go from -infinity. And as we keep going, the last value that we get to right here is +1. So always a parenthesis with -infinity. We were equal to the 1, so we're going to use a bracket with that. All right, then the range. So you can see this is going to keep going down. And this is going to keep going up. So that's going to be all real numbers. So -infinity to +infinity. We already talked about the one-to-one function. All right, so then f of 1, you can see there's a 1 in the place of x. So it's saying when x is equal to 1, what's y? And so we can come down here and see when x is 1, y is 2, that ordered pair right there. So then our answer would be 2. This next one says, where is f of x equal to 0? F of x is y. So it's saying when y is equal to 0, what's your x value? And so right here we can see the ordered pair -1, 0, that when y is equal to 0, our x value is -1. So -1 would be our answer. All right, for 70, they ask us to find the zeros of the functions. So zeros are the same thing as roots, x-intercepts, solutions. So basically I'm just going to factor this and solve it. So I'm going to take out the greatest common factor, and that leaves me a quadratic. So you could either factor that or you could put that in the quadratic program in your calculator, either one. But I'm going to take each of my factors and set them equal to 0. And so I've got x equals 0. This guy, I'm going to add 1 to both sides and divide by 2 to get the 1/2. And then this one, I'm just going to add 5 to both sides. So my solutions then would be 0, 1/2, and 5. All right, then for 71, they ask us to do our polynomial division. And this can be done by synthetic division because it's in the form of x minus k. So remember, minus means you're going to do the opposite of this number. So my k would be -4. That's what's going to go in my box out here. And then my leading coefficients across the top. So 1, +5, -7, +1. We didn't skip any terms to have to put zeros in for. So we're going to bring that 1 straight down. 1 times -4 would be -4. 5 and -4 would be 1. 1 times -4 is -4. -7 and -4 is -11. -11 times -4 is +44. 1 and 44 gives us 45. So when we start writing our answer, remember that we're always going to start with the power of x that is 1 less than the problem we were given. So this was x cubed, so we're going to start with 1x squared plus 1x minus 11, and this 45 will be our remainder. So they asked us to write the remainder as a fraction, so we're just going to take the 45 and put it over what we were dividing by, the x plus 4. Then it asked us, is that a factor? Well, if the remainder is 0, it's a factor. If the remainder is not 0, it's not a factor. Our remainder was 45, so no, it is not a factor. All right, Anna's going Black Friday shopping for clothes and a new laptop. She finds a laptop she wants for $900 and finds a sale on leggings for $20 each, and they want us to create a linear function that models the total amount, A, that Anna's going to spend on the computer and the leggings as a function of the number of leggings that she buys. Okay, so she's going to spend $900 on the computer no matter what. And then she's going to spend $20 for every pair of leggings. So we could just say 20 times L. So this is the amount she spends on leggings. This is the amount she spends on the computer. Put that together, and that's the total amount she spends. So for B, it says, how much will she spend if she buys 8 pairs of leggings? So we want to know what's the amount when the number of leggings is equal to 8. So let's just put 8 in for L. And we'll get 160 plus 900, or 1,060. All right, this next one says the amount she has to spend is $1,000. How many pairs of leggings can she buy? So this time they gave me the amount was 1,000, and we're solving for the number of pairs of leggings. So let's solve for L. So subtract 900 from both sides and then divide both sides by 20, and we'll have L is equal to 5 pairs. All right, then for number 73, there were 327 people in line at 5 a.m. at the Apple store, and the line grew at a constant rate of 72 people per hour. So there were 327 in line to start with, and then every hour, 72 more people got in line. So T is our number of hours. All right, so then it says how many people were in line by 8 a.m. Well, from 5 to 8 is 3 hours. And so we're going to put 3 in the place of T, our number of hours. So 72 times 3 plus 327 gave us the 543 people. All right, then it says the store only has 759 phones to sell to the people. So what's the latest time Davion would have to be in line to get one of the phones? So the number of people that are going to get phones is 759, and we want to know at what time that's going to occur. So subtract 327 from both sides and divide by 72, and we'll get T is equal to 6 hours. All right, so 6 hours from 5 a.m. If you do 5 a.m. plus 6 hours, that's going to give you 11 a.m. So you'd have to be in line by 11 a.m.